In episode 21 of Mobycast, we pick up on last week's conversation with part 2 of how to create effective container images. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Welcome, listeners, to another episode of Mobycast. And we have Rich, our producer, with us. Hey, Rich.
Hey, how's it going?
Good. And Chris.
Hey, John. Hey, Rich.
Technical expert and constant friend on Mobycast. Welcome. So, Rich, what have you been up to this week?
So last week, I was on vacation. And so this week is pretty much playing catch up from that vacation, which hasn't been terrible, but I'm a little bit underwater. So not a whole lot of fun, interesting things, just answering emails and trying to put out any of the small fires that I'd let kind of burn while I was gone.
Very cool. Welcome back from vacation. Although it didn't seem like you were gone because we worked virtually, and I think I had like 2 meetings with you while you were on vacation.
Yeah, I don't really know how to disconnect anyway. So
welcome back.
Yeah, good to be back.
And Chris, how about you? What have you been up to?
Let's see. Myself, I've been getting in a lot of bike riding, which is definitely my hobby of choice here during summers in Seattle. It's beautiful weather for it. Maybe a little bit on the hot side, but not complaining. And then also yesterday, I was fortunate enough to be in a small setting with a famous actor, Kyle MacLachlan, the actor from Twin Peaks, and also the mayor in Portlandia. So I was just a small setting with like 10 other people, and just chatting with Kyle for about 20 minutes. He's the winemaker for a very interesting wine called Pursued by Bear, and just got to hang out with him. So it was kind of just really down to earth guy, really easy to talk to, and it was very fun. Really enjoyed it.
That's super fun. We'll make sure to @him on Twitter about this episode. And then I have been not doing too much. We had some company in town, but then this morning I did something fun, which was giving a webinar about Docker. It was called Agility on Steroids with Docker. And I gave it for the Scrum Alliance group, which is the largest group that gives certifications and training for Scrum and other agile techniques. And that was super cool. And they recorded it. So we'll put a link to the recording on prodockertraining.com as soon as we can get our hands on it. Now, today, we're going to continue discussing a topic that we started last week. Of course, we've been doing several in a series of just recapping what we learned at DockerCon, which is great because we can digest it a little more slowly than, a 3-day conference, and we can pick only the stuff that was super interesting, and it stays relevant for at least a few months after it happened, so we can catch everybody up on what went down this year. Last year, we talked about Abby Fuller's talk. She talked about creating effective Docker images, and we got through about half of that. And, we always pepper in some of our own opinions, and we did that. And today we'll be doing the rest. So just to kind of, I think we should just recap a little bit, just at a very, very high level, like a few sentences of some of the things we covered last week and then some of the things we're about to cover today. Chris, would you mind doing that?
Sure, you bet. So yeah, last week we kind of dove into just the Docker file itself and images, and what they're composed of. So basically get into layers, how those impact your actual Docker image, how they starting with the right base layer kind of sets the framework for what your final Docker image is going to be, and how small it's going to be, and how performant it's going to be when building that image. Talked about cacheability, how Docker caches these layers and how that impacts the building of your images. And then we also talked about some tips around just what are the best practices for making sure that your images are as small as possible, and also as cacheable as possible.
Cool. I noticed in your notes here that there's one tip that we didn't talk about, the new experimental Docker build flag called Squash.
Yeah, I mean, we could kind of dive right into that a little bit. It's an experimental flag. It's not part of the stable builds yet. And really the intent behind that is that when you're building your Docker image, you can pass this flag to the Docker build command, and it will then go, and if you've in the process of building your Docker image, you're creating like 4 additional layers, that squash command will say, no, I want to squash those 4 layers into a single one. So it's a way of, again, reducing the number of layers and making your images smaller. This does have, this is one of those things where you can probably get bitten by it if you're not careful, where you have trade-offs with cacheability, right? So if you'd have to use it correctly. And I'm sure this is one of the reasons why it's still experimental, and there's going to be some education around it.
Right on. And we haven't used that in any of our work yet, but it's interesting. It sounds like something we might like to experiment with, especially if we start running it up against, weighty images that are hard to get into and out of registries that cause builds to take longer than we want.
Absolutely.
So yeah, for the rest of the day, looks like we're going to talk about multi-stage builds, security, garbage collection, maybe, I don't even know what multi-stage build really means. Maybe we can start there. What does that mean? Yeah,
so this has been an ongoing pattern in with Docker and building your images, where usually as you want to build your application, you're going through various different stages, right? So sometimes you may be needing to add things to your Docker image just to build artifacts. And you may need dependencies as part of that process of building the artifacts, but then those dependencies, you don't need them anymore in the final runtime image, if you will. So it's kind of, you can think of it maybe as kind of like compile time versus runtime dependencies. And so this has been just a kind of an ongoing issue with Docker images, and like, again, in the spirit of how do you make them as efficient and as small as possible. You basically want your final image, you want to end up with something that is just has the runtime support and doesn't have that compile time support, if you will.
I'm trying to think of a specific example, and let me run one by you and see if this is close. So I'm just thinking about Ruby on Rails, which is something I'm fairly familiar with, and some people that are listening might also be familiar. And I know that when you're doing a build with Ruby on Rails, at one point there's something that happens called precompile assets. And what that does is it'll take things like less or SCSS, like some non-compiled CSS stuff, and turn it into real CSS. And it'll take some JavaScript and minify it and just do a few other things. And it takes a long time. And at the end of that, you'll end up with actual CSS for your website and actual JavaScript that's minified for your website. And what you won't need anymore is any of the code that was required to create those artifacts. Could that be related to what we're talking about in multi-stage builds? Like maybe cleaning up after yourself after you do that compilation, that precompiling of assets?
Yeah, that's a great example. So those last files, they're not used in the final runtime, right? They're used to produce generated code. So it's really the generated code that is the runtime stuff, and the less code, that intermediate code is no longer needed. So that is exactly what like multi-stage builds. And then also, again, having there's been other techniques to get around this issue of like, how do I don't want to I shouldn't be including that stuff in my final Docker image if it's really not part of the runtime environment. So that's a great example in the JavaScript world. Another one would be like if you're writing code in ES6 and you're running it through something, a transpiler like Babel to output ES5 code, then it's kind of the same thing, right? So there's really no reason to have the ES6 code anymore. It's really just the transpiled ES5 code that you'd want in your final image. Maybe another example would be like you need to install a compiler in the tool chain to actually build like native code. So like it could be like C++ bindings for a few node packages.
So I always think about ImageMagick.
Sure.
Image
Yeah.
magic is a classic thing that you have to build into systems that, web applications.
Right. Yeah, exactly. So these are things that, you need them as part of the process of like building your final artifacts and the actual runtime support that you need. But after that, you only need it during the building process. So how do you get that, make sure that they're not part of the final Docker image? And so in the past, so multi-stage builds, this is a newish feature in Docker. It's been around for a little over a year now. But relatively newish. Before then, the way around this was basically do it yourself manually through using multiple Docker files. And so this technique is kind of similar to having your own shared common base image that you might have that's shared across multiple applications that you're building to kind of have an optimized, trusted base image that has the stuff that you need in it. This is kind of like the same technique, right? Where you would have multiple Docker files for your to build your final image, and then you have these different base images at each one of these stages in the pipeline and then you're just adding the stuff that you need at each one of these stages. So it ends up being, you could do it, but definitely a lot more work, and also a lot more just not very reusable.
I guess I'm a little confused by this because, my mind is like, wait, why don't I just build this stuff and then just delete the stuff I don't need? And I'm thinking that the reason that I can't just delete the stuff I don't need is because there isn't a delete kind of Docker file delete command, or if there is, it doesn't actually reduce the size of my image because the deleting is just another layer on top of the things that got added already. Do you know which of those it is, or if I'm just misunderstanding altogether?
Yeah, actually, I think one of the issues is there is no Docker delete command, right? So, like, in Docker, you have commands like add and copy. Those are actually aware of the content that it's putting on there, and it's actually doing checksums on the content that's been adding with that stuff. The other commands are run commands. So you could delete things with a run command. So you would do like run and then rm. But when you do that, it's not taking into account the actual content that's being removed. It just sees it as a run command. And now it's just
right. So it's just adding a layer.
Mm-hmm. So, and not only that, like, it's probably not like, how do you delete a compiler tool chain? Like, what are the how do you actually clean that all up type thing?
Right.
Maybe you can do it, using your favorite package manager and do an uninstall. But again, yeah, it's not really going to give you what it is that you need. So instead, you kind of want to have these starting from your base image, you're just adding to it. So it's more of an additive process than a subtractive.
Right. So then just to help me understand what would happen with multiple Docker images, in the first one, I would go and do a bunch of compiling after, I'd get my base image, and then I would put some files on it and compile those files. And then the results of the compilation would end up in some folder. And then in the second image, I would say, okay, get my base image again. And in this time, instead of compiling, I'm going to grab the stuff that ended up getting compiled from the other image and just put it directly in, already pre-built. Is that sort of what you're saying? So that the whole compilation step doesn't have to take place?
Kind of. It depends on the situation. This is definitely what we get with multi-stage builds in Docker. Using multiple Docker files, it's a little bit more complicated than that. And I think typically it's more along the lines of like, I have something that's for the development environment or my debug versus like my production build type thing.
Okay,
so,
got it.
And you can, it's kind of like it's very much an open-ended thing, right? And it's going to be very much specific to how you design it. So there's various techniques, and how you're dealing with the intermediate input, output from each one of these Docker builds is really kind of up to you. And that's where, again, it's like, that's why Docker implemented this multi-stage builds feature, because it cleans all this stuff up and makes it so much more intuitive and straightforward, and it really gets to the core use case of what it is that you're trying to do.
Got it. Yeah, it makes sense.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that John and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
Okay, so then how does the multi-stage build kind of work?
Right, and so at its core, it's very, very simple. And so what it is with a single Docker file, you essentially can have multiple base images.
Let me guess, sections? Oh, multiple base images. Okay.
Yeah, because really, so that what the pattern ends up being is you'll start off with, whatever base image you're using. You'll go and compile, build assets that will put artifacts out into some area of that particular part of the image. And then you can have subsequent commands that now say, I'm going to start with a different base image. Now I can go with my lighter image. So like maybe I started off with my full Ubuntu image because that has all my compile time support and all the other dependencies that I need. I went and go build all my artifacts. I know all my artifacts are going into a certain output directory as configured by my tool chain. And now I can have a second stage defined in that Docker file that says, I'm now going to start from maybe an Alpine base image, a really small, tight image. And then what I can do is I can say, I'm going to do a copy command. But the copy command, you can now give it, instead of just saying the files are coming from your local file system, you can actually have them come from one of the previous stages in your Docker file. So now I can say, basically copy my artifacts from that previous stage, and you specify like where you want it to come from. So really, really powerful. So it's totally aligned with this use case. It does exactly what it is that you need to do, where you're just plucking the artifacts that you need to pull into your image, type thing. So very powerful.
Yeah, that's super cool. That makes a lot of sense. And I think I get it now. It's like being able to refer to a different stage and grab files out of that. Like I don't think it needs much further explanation. So thanks. That helps. And I would guess we probably haven't had a chance to really try this yet.
No, I mean we do. We need to do it. It's definitely on the to-do list to go through. Obviously, it's a pretty big change across all of our projects.
Sure,
but.
Yeah. And it's like I said today on the webinar that I gave, that your CI/CD pipeline is always about halfway done. You're always like, no matter how long you work on it, you're like, yep, we're about halfway done.
Yeah. Never quite get there, huh?
Right.
That's just true with technology in general, right? It's like,
totally.
Like, hey, I'm up to date as of today. No, you're not, because there were some announcements yesterday. Sorry, you're now 50% up to date.
Cool. So now the next one makes me nervous because we've just already been talking for a long time, and you just can't even say the word security without having an hour-long conversation. But maybe, let's see, what do we have to talk about with security for images?
Sure. So actually, this one is pretty simple and straightforward, and it's not going to take much time at all. So again, this is a recap of the talk Abby Fuller gave at DockerCon 2018 about how to build effective container images. And again, one of these topics of the discussion was, security. What can you do around images? And so pretty straightforward with images, use a scanning service. So basically scan your images for known vulnerabilities, and to be alerted of it. So it's, things like, hey, there's maybe there's a bug in Ubuntu, a security issue with Ubuntu. distribution, a certain version number, and you happen to be using it. So if you use one of these scanning services, they're going to let you know that, hey, you're using this code that has this known vulnerability. There's multiple of these scanning services out there. I think we've touched on this on some previous Mobycast episodes. So there's a mixture of paid and free tools out there. So there's really no reason not to do this. So check out Microscanner from Aqua. That's an open source. The community edition is a open source free tool. There's also Docker itself. They have their security scan with their trusted registry as a paid product. And then there's other offerings like there's Claire from CoreOS, and there's others out there. So definitely give that a look. It should be part of your process of just building your Docker images, put them through a security scan, and just see if there's any binary code there that just is not safe and has known vulnerabilities, so that you can go in and patch it up.
That's pretty cool. Yeah, there's scanners at every level now. You can scan your repository, and then later, after you build everything, you can scan your image.
Mm-hmm. Absolutely.
Cool. Well, next, what is Docker garbage collection all about? I know what it is in programming languages and like running, Java garbage collection and Objective-C garbage collection, et cetera. But what's Docker garbage collection?
Yeah, so Docker garbage. So using Docker and the whole life cycle of creating images, running those images, and then lather, rinse, repeat. This actually ends up taking lots of space, especially disk space. It creates a lot of artifacts, and at the end of the day, garbage. So you go back in the day when Bill Gates said, "I can't imagine any computer needing more than 640 kilobytes of RAM or something like that." He didn't know about Docker. So there's a lot of so with just about every one of the primitives of Docker, the fundamental elements of the Docker tool chain will have these artifacts, right? So you have images, you have containers, you have volumes, you have things like even networks. All these things, as you are going through the Docker process and running them, they will hang around potentially, and they're not going to get necessarily cleaned up automatically. So it's kind of up to you to
which could be a good thing, right? That could be a good thing, because what we want when we have lots of containers running on a machine is like fast startup. So keeping them around can really help with that startup time.
Yeah, absolutely. And there's also things like cacheability, right? Layers and yep. Making sure that those layers are there. So there's definitely, some trade-offs, and it's going to be very dependent upon your environment. And that's one of the reasons why Docker doesn't do it automatically for you. And so, you'll find if you do, there's a difference of talk about garbage collection with Docker. There's different techniques for doing it locally versus in production. Locally ends up being definitely much more of probably a manual process. It's kind of up to you as the individual to deal with that. In production, you can rely much more on your orchestrator to do this. And most of the orchestration systems will clean up for you automatically. So I'm talking about that. For production, we use Amazon ECS, the Elastic Container Service, and that has its own built-in garbage collection. So there is an agent piece of software that sits on each one of the nodes in the ECS cluster, and that it just takes on the task of every once in a while it goes through and just cleans up any images that are no longer being referenced by any containers, any containers that are stopped and no longer being used, and just keep making sure that it's being kept relatively clean. And that's important, because if you don't do that, the net result will be, at some point you're going to get try to start a container, and you're going to get an error saying, "Sorry, we couldn't run this container because there's no more room on disk." You're going to run out of disk space. So again, it's much better now. The orchestrators have gotten more sophisticated and they give this to you and you don't have to worry about it as much. A couple of years ago, that definitely wasn't the case. And this was one of the ongoing problems of running Docker in production was, how do you keep your disk clean and not run into this issue of running out of space? On the local side, to do it yourself kind of manually in the past, again, it's been more difficult where you'd have to kind of by hand do this and individually remove images. Very tedious process. But recently Docker's added some nice commands into it. So these are the prune commands. And so now you can say, if you want to just get rid of all the images that are no longer being used locally, you just run docker image prune -a, and that will blow them all away for you. So what used to take minutes of time is now something that just is, instantaneous. It's really easy to do and no reason not to do it. There's, in addition to pruning images, there's also the commands for pruning networks and for pruning containers. And then there's an Uber command called Docker system prune, and that will do everything for you in one fell swoop. So definitely check that out. Make sure you're doing that, keeping your disk and good, from getting clogged up with all these Docker artifacts, and you'll be good to go.
Super helpful. We have one more point on the list of notes that says takeaways, and I'm not sure if that was an additional thing that we wanted to talk about or if we just wanted to wrap basically right here.
Sure. Yeah, we can just kind of wrap up quickly, which is kind of like the overall takeaways from this particular session at DockerCon. And so, just in a nutshell, the major takeaways from this were, one, less layers is definitely more, right? So strive, really think about how you're building your Docker images and strive to keep the number of layers minimal. You also want to share layers where possible. Basically this concept of reuse, so that you don't have to reinvent the wheel for every single one of your applications. So strive for that. You also want to choose or build your base image wisely. So it's kind of like you're not going to be successful if you don't start off with a good base image, with the right base image. So that's a pretty important choice. And a lot of times people don't put too much choice into that. They choose that base image based upon convenience, not necessarily on what's going to generate the best possible final image. So definitely consider that strongly. Also, another key takeaway would be that, not all languages should build the same. So how you build a Docker image for a Node application is going to be different than how you build one for Rails. And so don't treat them the same. So there are application domain specific techniques that make more sense. And a lot of the times this deals with how dependencies get installed and cacheability and whatnot. So definitely keep that in mind. And then, finally, just keep it as simple as possible and avoid the extras. So keep the surface area small and only put in there what you need.
Super good. Well, I certainly learned quite a bit here. I'm about ready to stop my job as a person that runs a company and become a Docker developer. I appreciate it, Chris.
Awesome.
Thanks so much. And Rich, producer Rich, thanks for joining us as well.
Yeah, thank you. All right. Thanks, guys.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/21. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.